Hi there, and thanks for tuning in. Today we're going to be looking at 3.7 Part 2, Graphing Absolute Value Equations. We are going to be looking at a specific thing called vertex form, and you're going to be getting a study sheet to help you with that today. You do need graph paper for this pair of notes, so let's just make sure you have that ready. And we're only going to be writing down 4 things today, plus what's on our study sheet, so let's go ahead and get started. The first thing we're going to write down is what is vertex form. So an absolute value function written in the form of g of x, and remember you can replace g of x with usually anything, is equal to a with the absolute value of x minus h plus k. A cannot be equal to 0, and the vertex of the graph would be found with the numbers h and k. Any absolute value function can be written in vertex form, and it's also going to be symmetric to the line where you have x is equal to h. So that x is equal to h will show you where your vertex would be showing at. Okay? So what we're going to do is take time now to pause the video here so you can write down what is highlighted, and then once you're done, click play, because we're going to fill out our study sheet together that we get in class. Alright, so the next thing we're going to do is fill out this study sheet. So you are getting one of these in class. This will be good for you to use while you're doing your homework tonight, and then also help you review for your test. So what we're going to do is fill out this. This is just a reminder that what your parent functions look like of standard form, and the vertex can be found at h comma k. The line of symmetry is x is equal to h. And sorry, this should be written as, there's some formatting here, g of x is equal to the absolute value of x, and then this is still your normal parent function as before. Okay, so we're going to start here in this first section. K, translate the graph vertically, so that would just mean your up or down, or this is going to be your y-axis. Notice where K is located in that vertex ordered pair. If K is positive, then the graph will shift up, but if K is negative, the graph will shift down. Okay, so we have a few examples here. The first one we're going to look at is just an example. If we have g of x is equal to the absolute value of x plus 3, that transformation would be a translation 3 units up. And the sketch would maybe look like, so you're just going to draw yourself a little graph here, and we're just going to do the parent function, but translate it 3 units up. So if we have 1, 2, 3, that means our graph would be about here as far as absolute value goes. Okay? For the next one, though, we have g of x is equal to the absolute value of x minus 4. That one would still be a translation, but it is 4 units down. So once again, if we maybe plotted this on our graph, that give me some more room down there. And parent function would be at 0, 0, so translating 4 units down would be negative 4. So our graph would be like this. Okay, so those are pretty simple. Let's go ahead and move on to the H section. H would translate the graph horizontally. So if H is positive, the graph will shift to the right. And if H is negative, it's going to shift to the left. Okay, so our first example, we have g of x is equal to the absolute value of x minus 2, and notice that these numbers, the minus 2 and the plus 1, are in position of where h is located in your vertex form, with the x inside the absolute value. This one would be a translation, and this is actually going to be 2 units to the right. Okay, the reason is because, and I'll show you this in an example on the next one, you could also have this one down here be g of x is equal to the absolute value of x minus negative 1. So that is where you see your negative 1. So that would mean a translation 1 unit to the left, because the 1 is negative. Okay, so this 2, you're basically just looking at it like that. It's a positive, it's going to go right. This one, though, can be a negative. So basically you're just thinking opposite there. So if you're sketching this first one, the absolute value of x minus 2, that is 2 units to the right. So parent function is at 0, 0. 2 units to the right would just be 1, 2. And then graph. But if you translate 1 unit to the left, again, parent function is at 0, 0. And that would be 1 to the left. Okay. The next part is A. So remember, A is located here at the very front, so right before the absolute value, and basically like you're multiplying that stuff in absolute value form. This one is going to be a stretch or a shrink in the graph and may reflect the graph across the x-axis. So we're going to talk about two different things here. If A is positive, the graph will open upward, but if A is negative, it opens downward. Okay, if A is greater than 1, the graph will stretch closer to the y-axis. But if A is in between 0 and 1, like a fraction, that will shrink closer to the axis. So if we have 1/2 x, this will be twice, oops, we're up here, 2 absolute value of x. This is twice as narrow as parent graph. And the reason why it's twice as narrow is because when you're multiplying stuff by 2, you're going to increase your values twice as fast. So your parent value would be like this, twice as fast would be like this, where it just goes straight up really quickly. Okay, so since that is a whole number, we're going to be talking about a stretching closer to the y-axis. So this is considered a stretch. Here, this is twice as wide as the parent graph, because it takes a little bit longer to get to your values. So twice as wide would look very slow in that regard. Okay, and this one would again be called a shrink because it is in between 0 and 1. If the graph was negative, then that means it's just a reflection across the x-axis. Okay, and that was going to look like, let's get my page down, this. Here's your 4 quadrants. Reflection across the x-axis would just be this. So all your values end up being negative no matter what. Okay, so this is your study sheet. You should have been pausing maybe as you go, but if not, let's pause or rewind so that you have all the things needed for this study sheet. I'm actually going to stop the video here and I'm going to continue on a new video on the next one in this playlist. Thanks for tuning in, and we'll catch you right back up in just a moment.